This time, another shift. What direction? Which way is it going? It's going to the left. Okay. So this time, again, I start with my asymptote. My asymptote's going to move 1 unit to the left, right? So here it is. It's no longer at x equals 0. It's now at x equals 1. Okay, -1. There we go. Over there. Now, being that that part of the graph has moved, the intercept has also moved. The intercept was at 1, wasn't it? Right? So now it's going to be at
0.
The origin. Okay, so draw your graph cleanly through. Okay, alright, I was pretty close. That's moved. I might as well also move my point for scale. Right? That was at 2, 1. So now where should it be? 1, 1. Again, you're kind of locked in to where x equals 1 has to be, because I already put in x equals -1. So that distance must match, absolutely. Okay. Alright, question 4. What's the difference? Again, I sort of think about all of these in terms of that original graph that I started with. So how would you articulate the difference? Yeah.
Every point on the graph is times by 3.
Yeah, good. Okay, so I would add on to that vertically multiplied by 3, right? So if I take out this this vertical asymptote, it's still in the same spot, still at x equals 0. Okay, what happens to our intercept over here?
It comes through.
Now, because our y value, let's go back to what you mentioned, Nikita. Because our y value for this intercept is 0, when you multiply 0 by 3, you end up with 0. So that stays put. That point always stays put. Okay. Now, when I draw this through, what has changed? Because this is what we alluded to before. Graph 1 and graph 4 look identical at the moment. So what must I adjust?
Scale.
This point for scale, right? Before it was at 2, 1. Right? If I pick 2, which is still going to be twice as far away from the y-axis, right? It's not going to be 2, 1 anymore. It's going to be 2, 3, because it's 3 times higher. Okay. Now, when I put that across here now my scale is all off in terms of y and x, but that's okay. That's okay. This could be 3, it could be 300, it could be 3 million. So long as it's consistent with itself and the x-axis is consistent with itself, all fine. Okay, and by the way, if you have a template, right, your template should have a log graph on it, and so you can use this same one for all of them. Maybe I should swap with you. I should get you another one. Yeah. Say that again? You're talking about another point, you mean? Yeah, yeah. So you can pick that, or you could go in here. It would also be fine.
What do you need? You only need 1 point.
So in general, for as many branches as your graph has, you should have a point for scale. Right, for as many branches as your graph has. And these all have 1 branch. Okay, now, question 5. Question 5, I'm not going to graph. I'm not going to graph. Or perhaps I should say, I've graphed it already, right? Have a look at this. Before you dive into any pen to paper, right, what could you do with this to make things easier for yourself? Yeah.
Let 2x equal to capital X.
No.
Change the program? I could do that, I suppose. I'm not sure if it would help. What would you suggest?
To log base 2 plus log base 2.
Okay, alright. So this guy in here, this is a product, right? So this is 2 times x. If it's 2 times x, I can break that apart, right? So as suggested, I'm going to take the 2 here, and then I'm going to add that to the x. But we know what log base 2 of 2 is. It's just 1. So I'll just put that around here. So you can see I've already graphed this graph. It's right here. Now, before I move off that, like, cool, I've done it already, right? What does this mean? What does this mean? Because we started to graph this by saying, okay, I've moved up. That's what I've done. Okay? But this does not mean move up. Why did this become move up? We already know what this means, right? Yeah.
Because the 2x means that you're compressing the graph.
Yep.
And that is basically, if you moved it up, it sort of compresses it at the same time.
Yeah, very good. Now, in case you didn't catch that, right? This is about a vertical shift, right? And this is about a compression factor, right? Just like if you got y equals x and y equals 2x, 2x has been squashed in, okay? This is getting squashed in as well. Compare these two. It's not just that this moved up. Now it's like, oh, of course the intercept should be a half, right? Because it's now twice as dense, right? Just like sine 2x is twice as dense as sine x. Does that make sense? Right? And that's also why you've got 1, 1 instead of 2, 1, right? Everything is packed into a smaller space, right? So just like we looked before and we said, oh, you know, with y equals x, a horizontal reflection and a vertical reflection happen to be the same thing. Because of the nature of logs, a horizontal stretch or compression is the same as a vertical movement up or down. Okay? Bit of an interesting idea, but the algebra speaks for itself.